Okay, turn to section 1.13, page 10, and we're going to skip number 1, but go ahead and read all this and all this vocab, and then go through that, pause, and we're going to do number 2 in just a second. So pause, read all this, and then we'll come back. Okay, so look at number 2. We're going to draw a Venn diagram, and one is going to be constant and the other is going to be variable. And so then we're going to kind of make a Venn diagram and kind of put things in there. So if I grab a pen here. All right, so here we have our big Venn diagram, and then we're going to make our 2 circles. And we're going to compare constants, and we're going to compare variables. All right, so why don't you pause for a second, try to think of things that would go in the middle that they have in common, constants and variables, and then over here, things that are only constants, things that are only variables. And again, you could put examples, you could put some definitions here. If you need to go back a page and again, reread constants. Variable, I think, is on page 19. So if you want to go back to page 19 and read what a variable is, you can. Try to fill this out and we'll come back and look at it together. Okay, so if we look at our Venn diagram, and we're not, obviously there's infinite many things that could go out into this nothing space, right? So we're going to kind of ignore that and just look at what they have in common and what they don't. So constants are numbers, and they don't change. So like 0 is always 0, negative half is always negative half, pi is always worth pi, 3.14159, ... 8 is always 8, 10 is always 10. So the reason we call them constant is because they stay constant, all right? Variables are things that can change. So the value, like x might sometimes be worth 10, sometimes a negative 10. This might be worth 3, sometimes negative 3 others. We use letters to represent them. Sometimes there's capital letters like A for area, things like that, okay? But they do have something in common, all right? And that we use them in algebra, so we use both numbers and letters, and they're in equations and expressions. And you could have put some examples in here like 2x plus 8 or something. We have a variable in there, we have some constants in there, you know, so that would kind of be an example maybe of something that has both. All right, so go ahead and try number 3 on your own. This time we're going to make a Venn diagram again, focusing just not on this outside part, but on these 2 parts. And you're going to compare what? Expressions and equations. So again, if you need to go back to page 110 to read what those are, read what they are and make that Venn diagram. So I'm going to pause and work on. Okay, so let's look at some things that are true about expressions. So expressions are kind of like chunks. So they have like 8 could be an expression, 2x minus 5 could be an expression. So they do not have sides. So there's just one chunk. There's not 2 sides to it. They're not true or false because, you know, I could put 5 in there for x. I could put 10 in there for x. So it's not true or false. And then the directions are usually to simplify. With equations, we do have 2 sides, and that's because we have an equal sign. And so when we have an equal sign, we have one side and another side. So we have 2 sides. Definitely have an equal sign in there. They could be true or false. So like, for example, if I say x is 0, shoving 0 over here, negative 8 doesn't equal 0. So that's a false statement. It's not true, but it could be true depending on a different value. All right. So if I say, you know, maybe x is worth, I don't know, negative 8, then, you know, that might work. So if I shove in a negative 8 over here, I get negative 24, negative 32, and that does equal negative 32. So negative 8 makes it a true statement, where any other number makes it false. And then the directions typically here are solve. So we solve the equation. Over here we simplify, over here we solve. Now, as far as what they have in common is they both have terms, which are chunks of algebra stuff. And then they have variables and constants both. So they could have both. All right. Okay, so why don't you keep reading and flip the page to page 112, and I'll meet you there. Okay, so on the top of the page, factors are things that are being multiplied. So we have 3x minus 12, what is it, y, I think, something like that. But whether there's a dot here or not, if they're touching, these things are multiplied. So things that are being multiplied are factors. So the 12 and the y, those are both factors. But the terms are the chunks. So like this is a chunk that's kind of glued together, and this is a chunk including the negative, because if you added the opposite, that really is negative. So terms are chunks that are separated by addition. So you might have something like this, right? And so the terms include the sign in front. So that's a term, a term, a term. So terms are things that get added together. Factors are things that are multiplied. So like 2xy, these are all being multiplied. So each of these are factors. Or if I have 2 or x plus 2, x plus 3, this chunk is being multiplied by that chunk. So those would be called factors. All right. So go ahead and try to fill out the chart below. You can look at the example below, but then try to fill in the chart on number 4. Okay, so on this one, we're looking at kind of what are the 3 and the y up above. So if you look up above, here's your 3 and the y. So what's happening to them? So 3 and y are touching each other, which means they're multiplied. So they must be factors, because factors are things that are multiplied. Here they're saying what is the relationship between the 3 and the y glued together, so as a chunk, and the 4. So if I look at the 3y as a chunk and the 4 by itself, they're being added together. And things that are added are terms. Okay, and then here it's asking about what are the 2 and the 3. Okay, now the 2 and the 3, you could say that they're constants. That's one answer. That would be okay. But a better name is when there's a number in front of a variable, we call it the coefficient. So these are both numbers in front of a variable, so you could use coefficient. That would probably be a better term. But you could use constant. And technically, you could probably even say factors, because the 2 is being multiplied with the z and the 3 is being multiplied with the y. But the best name is when a number is in front of variables like this, we call it a coefficient. And again, you can go back and read the vocab. All right, let's look at x and a -1. So x and a -1, what's happening with them? So here's your x, here's your -1. So technically these are being added, and if you can't see that, you can add the opposite and see that, but this is being added with that. So those are definitely terms when they're being added. All right, and this last one, we're looking at the 2, the z, and the x minus 1. Okay, so we're looking at this 2 by itself, this x by itself, and then this chunk, x minus 1. So we're looking at the 2, the z. So what are happening with those? Well, if you look, this and that chunk are all being multiplied. So they must be factors. Okay? All right, so again, if I have a chunk of something like this, okay, the individual pieces, like the 2x and the 3y and the -8 are being added. So they are terms. If I look at what's happening just with the 2 and the x, they're being multiplied. The 3 and the y are being multiplied. Can't remember if that's negative or positive, not sure. But if it's negative, the negative would go with it. So -3 and y would be multiplied. And then the -8. So those are all chunks. So those are terms. But then these are being multiplied. So they are factors. And as far as constant goes, 2 stays 2. That stays that stays that. Those are constants. And then coefficients would be, again, these numbers in front. So, and even -8, you can consider it a coefficient because there's like x to the 0 power there or something like that. So make sure you reread the vocab and make sure you do it. And go ahead and read the vocab on the bottom of page 113, and I'll meet you at the top of page 114. Okay, so polynomials are just things that are added together. So they kind of look pretty nice usually. The exponents are nice whole numbers. So maybe like 20, you have 18. You could have anything for coefficients. That's not a problem. But the exponents have to be nice whole numbers. So like x cubed plus x squared minus 8x plus a half. All your exponents are whole numbers, you're good. You can't have anything x's in the denominator because technically x's when they're in the denominator are actually negative exponents. We haven't talked about that yet. So these have to be whole numbers, meaning positive. You can't have negative. You can't have ugly exponents like, x to the square root of 3 or anything ugly. So just nice little whole numbers for exponents. The degree is the highest one. So if I give you something like this, the degree of the whole polynomial would be 3 because that's the highest exponent. So the first one has 2 parts to it, so like a bicycle, so we call that a binomial. And the degree is the highest one, so it's 2. This one, we have all nice exponents. This is a 1. We don't write it, but it's there. So they're all nice whole number exponents. And we have 3 parts, 1, 2, 3. So we call it a trinomial, kind of like a bicycle has 3 wheels. So we call it trinomial. And the degree is the highest one, which is 2 again. The next one is, some people are like, but there's no exponent. Technically, there's an x to the 0 power there, like 4x is 0 power, but anything to 0 power is 1, so we don't really write it. So we have 1 chunk here, so it's called a monomial. It's also a constant, but it's called a monomial. And then the degree is 0 because technically it's x to the 0 power. So there is no exponent, so that's another reason it's 0. The next one has all nice exponents, so it's a polynomial. We don't have any names when they're more than, 3. So we have a monomial, binomial, trinomial. Sometimes people call this like a four-nomial, which is kind of a made-up name. And then the degree is the highest one, so the degree is 3. The next one has an ugly exponent, not a whole number, so this one is not a polynomial. So it is not 1, because you can't have a decimal exponent. The next one has a nice exponent, so it's good, and it's 1 chunk, so it's a monomial, and the degree is 3. The next one has nice whole number exponents, and you have 2 chunks, so it's a binomial, and the degree is the highest one, which is 4. And the last one is not 1 again, because you can't have x's in the denominator, so this is definitely not 1. All right, that's about it for that section. So for the homework, you can do 1 through 2 and 4 through 7 on page 115. So again, you might need to recap the vocab. Things that are added, like chunks like this. Let's see, what am I doing there? Say 2x squared plus x plus 8. That these are the things that are added are these chunks, including if they're negative. Okay, so maybe if this was minus, we would include the negative with that. But these are called terms, things that are added. Things that are being multiplied, like this and this, are touching, they're multiplied. Those things are called factors. So like this and this would be factors. The negative 2 and x would be factors. The numbers in front of variables, so like the 3, the 4, including the negative, those guys are called coefficients. And constants are things that don't change, like this 8. Oops, I'm sorry, I don't know why that happened, but the 8 would be a constant because it doesn't change. And technically this negative 2, the 4, and the 3 are constants too because they don't change, but coefficient's probably a better word. And then all of this is called a polynomial. And this has 1, 2, 3, 4 parts, so technically it's just a polynomial, but you could call it a four-nomial. And then the degree is the highest power, which in this case is 3. All right, so again, you might want to review equations versus expressions, variables, all that good stuff. And then, do the homework. This one's mainly vocab.